Section 8.2, solving systems algebraically. So algebraically solving a system of equations in two variables means determining the values of any ordered pair that satisfy both of the equations in the system. So just like before, if we have a line and a parabola, it can never intersect. It can intersect once or it can intersect twice. And similarly with parabolas, they can infinitely intersect. They can be the same parabola. They cannot intersect at all. They can intersect at 1 point or 2 points. So we're just finding all those points of intersection. To solve a linear quadratic system, you may use either substitution or elimination. Both methods will give you the same solution. Okay? So substitution means that you just, if y is equal to x squared minus x minus 6, and y is equal to x minus 3, then those two things must be the same. We've substituted x plus 3 in for y. Okay? And then once we get a solution, we have to put it back into the original equation. Okay? And then elimination. Elimination is a little different than what you might be used to. Not any more difficult. You'll find that you like one or the other, and you'll be able to recognize which one's easier to do. Since both equations are equal to y, the second equation can be subtracted from the second one to eliminate y. Then we solve for x. Okay, so we eliminated, we factor, and we solve. Here's another example. It says to solve a quadratic, you must use substitution method or an elimination method. When solving, you cannot eliminate x, so you must always eliminate y. So just don't go eliminating x's is what they say. Okay? Two really good examples that you can look at your leisure. I just want to read the bottom here. For both types of systems, remember to take the values you determined and substitute them into the original equation to find the corresponding values of the other. So if you find x, sub it into the original equation to find y. If you find y, sub it in to find x. You should always verify solutions by substituting to both of the original equations. To solve a linear quadratic and a quadratic, you must determine the solution to a quadratic equation. Remember that to solve a quadratic means determine the x-intercepts. This can be done by factoring. It can be done with the quadratic formula. You could even do it graphically if you wanted. Okay? And then once you determine a value of x, you substitute into the original equation and determine y. Okay, let's give it a try. So this is example 1, solving a linear quadratic algebraically. Solve it algebraically and verify your solution. So let's try substitution first. Okay, so what we need to do is we need to get them both equal to y. Actually, only one equal to y. Let's get this one equal to y because it's smaller. So we could say that negative y is equal to 2 minus 2x. So I could say y is equal to negative 2 plus 2x. Now I'm going to substitute this into the first equation. This will give me x. So x squared minus x minus y, and instead of y I'm going to put negative 2 plus 2x is equal to 6. And now I'm going to go about solving this. X squared minus x plus 2 minus 2x minus 6 is equal to 0. X squared minus 3x minus 4 is equal to 0. So what I get is, let's see if I can factor this guy. So two things that multiply to be negative 4 and add to be negative 3. So I have x equals 4 and x equals negative 1. Now what I must do is I must plug these numbers in to get my y value. So let's try x equals 4 first. So 2 times 4 minus y is equal to 2. 8 minus y is equal to 2. Y is equal to 6, because 8 minus 6 equals 2. Okay, so our first solution was 4 and 6. Okay, now the other one was x equals negative 1. So 2 times negative 1 minus y is equal to 2. This is negative 2 minus y is equal to 2. Adding 2 negative y equals 4. y equals negative 4. So our other point is negative 1 and negative 4. So these are our 2 points that we say are solutions. That makes sense. This is a quadratic and a line. Quadratic and a line, so we're saying there's 2 points. But the last part says I must verify. So to verify, I need to sub in to both original equations and make sure that they satisfy those equations. Okay, so first of all, let's try this 4, 6 guy. Does 4, 6, we are verifying 4, 6. So I need to put it into both equations. So in equation 1, x squared, so x is 4. 4 squared minus 4 minus 6 equals 6. Does 16 minus 4 minus 6 equals 6? Does 16 minus 10 equals 6? Yeah. Now let's check equation 2. Does 2 times 4 minus 6 equal 2? Does 8 minus 6 equal 2? Yeah. Okay, so that has been verified. Now let's verify negative 1, negative 4. Okay, so I have x squared, so negative 1 squared minus negative 1 minus negative 4. Ooh, negatives and brackets are important here. So I have 1 plus 1 plus 4 equals 6. Yeah. Number 2, 2 times negative 1 minus negative 4. Does that equal 2? So I have negative 2 plus 4 equals 2. Yeah. So I have verified that this is the solution. I'm just going to write my solution up here so I don't forget it. Okay, so that was using substitution. And now we're going to try and use elimination. So x squared minus x minus y is equal to 6. So in order to use elimination, let's just go back here and read our rules. So using elimination, it says since both terms equal y, the second equation could be subtracted from the first to eliminate y. So I think in this one it might be easier if we solve for y. So here I'm going to get y is equal to, I'm going to bring y to this side and 6 to that side. Y is equal to x squared minus x minus 6. And in this equation, I'm going to bring the y to this side and the 2 to that side. Y is equal to x, 2x rather, 2x plus 2. Okay, and what they said I had to do is I actually have to line these up so they're with their degrees. So 2x, and that was a minus 2. And now I subtract. So I get x squared, 0 is equal to x squared. Negative x minus 2x is minus 3x. Those negatives are going to come in handy. Negative 6 minus negative 2, so that's like adding 2, is minus 4. And now I have to factor this. So I get x minus 4, x plus 1. So I get x equals 4 and x equals negative 1. Lo and behold, guess what? I got the same x values, and you know what? It's the same process to get those y values. I'm going to sub back in and spit it out and verify. So it doesn't matter which method you use for whether it's elimination or substitution, you should get the same answer. However, I will get you, specifically I will say, solve this using substitution, solve this using elimination. So you can't just be a one-trick pony. You need to know how to do them all. Okay, solve a system of quadratic equations. Solve the system algebraically. Verify the solutions in the original equations. Okay, I'm going to use elimination to start with. So what I did is I solved each of these equations for y, and now I'm going to use elimination. So y minus y is 0. 3x squared minus 2x squared is 5x squared. Negative 24 minus 16 is negative 40x. And positive 52 minus negative 28 is going to be 80. Minus 80. Okay, so now I need to go about factoring. And I see right away that I have a GCF. So I'm going to take that out. X squared minus 8x minus, ooh, what's 80 divided by 5? Is it 20? I think it's 20 times 5, 40. Geez. No. Okay, 80 divided by 10 would be 8, and it's 16. There we go. Okay, so I need two numbers that multiply to be negative 16 and add to be negative 8. Okay, so it looks like 4 and 4. If I have x minus 4. But that won't give me a positive, will it? This should have been positive. Let's see if that's right. Did I do this wrong? I did. That was supposed to be positive. Okay, that's where my mistake was coming from. Because I had positive 52 minus negative 28. There we go. Okay, so I have x equals 4 and x equals 4. Okay, so now what I need to do is I need to sub this into the equation and see what I get for y when x equals 4. So I'm going to put it into this first equation. Let's try that. I have 3 times 4 squared minus 24 times 4 minus y equals negative 52. Notice I used the original equation, not how I changed it here, just in case I made a mistake. Okay, so that's 3 times 16 minus, that would be 16 plus 80. 3 times 60 would be 30, 48. 48 minus 96 minus y equals negative 52. Getting y by itself, I get 48 plus 52 minus 96. So 48 and 52 would be 100, minus 96 would be 4. Y equals 4. Okay, so let's double check y equals 4. Let's double check that the point 4, 4 is a solution of both of them. Okay? You know what? That's too long. That's too long for the video. You guys can do that math, but what you need to do is I would need to substitute into this first equation and check it, and then I would also need to substitute into the second equation and check it. Okay? And if both sides were equal, then I would have verified that this is a solution.